Number one, greatest common factor and factor by grouping. We're looking at this first example to find the greatest common factor, which we'll abbreviate as GCF, greatest common factor. So what you want to do, there's a few of these first three examples where you actually go through a method that it's not really common once you get into factoring polynomials, but for these first three examples, make sure you take down the notes because you'll want to use this process on the examples that look like this. So here they give you three different terms and you want to find the factor that's common to all of them. We'll start with writing down the first term and then we'll break it down as far as we can. 3 doesn't break down at all. 3 and then times x and then times y. 21 will do the same thing, 21x squared. Only if you break 21 down, and I'll do this on the side here just to show you how we work this out. 21, you just start with two things that multiply to be 21, 3 times 7, and you break down any of those factors that can be broken down further. 3 can't be broken down any further, 7 can't be broken down any further. So we end up with 3 times 7, that takes care of the 21 part, and then the x squared part, that's x times x. Then going on to the 9x cubed y. 9 we could break down if we did that on the side here. That'd be 3 times 3. And then the x cubed is x times x times x. And then we've got 1y. So for your greatest common factor, want to emphasize the common part. So we're looking for factors that are common to all three of those terms. Here we've got 3. That's common to all of them. But we don't have a second 3 that's common to all of them. If we look at x, we've got an x, an x, and an x that's common to all three of those terms. So we can tack an x onto there. We can't do another x though because there's not a second trio of x's that are in common. And with y's, we're not going to add a y on there because there's no y here on the second term. So 3 and x are the only terms that are common. We do go ahead and multiply those. 3 times x just gives us 3x. And that's our greatest common factor. Number 2, find the greatest common factor of 42 and then 14xy squared. So 42, I'm going to write out its prime factors, and then 14xy squared, we're going to do the same thing. So for 42, you might make what's called a factor tree here. So start with two things that multiply to be 42. Doesn't really matter what they are. Just as long as whatever they are, you break them down as far as you can go. You can go with 6 times 7. You can go with 21 times 2. 7 doesn't break down. 6 does. 2 times 3. And 2 doesn't break down. 3 doesn't break down. So we've got 2, 3, and 7 make up the 42. 14, maybe you can do this in your head. That's 2 times 7. We've also got an x. We've also got 2 y's. And then our greatest common factor, again, I'm going to emphasize the common part. We've got 2 in both of those, but no 3 in both of those. We've got 7 in both of those, so we want to multiply 7. We don't have x that's common to both. We don't have y that's common to both. So this is it. If you go ahead and multiply those, you get 14. Number 3, we're finding the greatest common factor of 3 terms here. We got 35x squared y squared, x squared y squared, and 5x squared y cubed. So 35 breaks down to 5 times 7. We've got 2 x's. We've got 2 y's. X squared y squared doesn't have any numbers, but we've got 2 x's. We've got 2 y's. Five x squared y cubed, no x's or no numbers that we can break down other than just 5. But we've got 2 x's and we've got 3 y's. So we've got 5 in 2 of them, but not in all of them, so it's not common to all. We've got a 7 in 1 of them, but it's not common. Got a trio of x's, so we're going to have one common x. We've also got another trio of x's, so we've got a second common x. We've got some y's in common, 2 of them. But not a third trio, so we end up with x times x, which is x squared, y times y, which is y squared. So again, that's not a method that you'll do very often as you go through algebra, but it'll come up on these first 3 problems. Number 4, factor. We've got 35x y squared plus 15x cubed y. Anytime that you see a direction asking you to factor, you'll want to check to see if there's a greatest common factor. First of all, I mean, that's all that we're doing in this section, but as time goes on, we do more and more factoring. Keep in mind that we want to see if there's something that we can take out, something that's common right at the beginning. And if you look at both of these terms, if you look at the numbers, just the numbers themselves, 35 and 15, hopefully you can spot something that's common to both of them. 5 goes into both terms. Also, if we look at the variables, we've got an x and x cubed. X is common to both, and just one x is the most that we can take out. We can take 1x out of this term. We can take 1x out of that term. If you ask yourself, can I take out 2 x's? Well, the first term doesn't have 2 x's, so 2 x's would not be common to both. But 1x is common to both. If we look at the y's, we can take out a y in both, but we can't take out y squared. So what we'll do is we'll figure out what that common factor is, and then we're going to rewrite what's left when we've taken that out. Basically what we're doing is we're dividing. So 35 divided by 5. We took out an x. We took out one of the y's, so that left one y in that first term. So this all divided by that 5xy that we took out. Then we want to take 15 divided by 5. That gives us a positive 3. We took out one of the x's, so that leaves 2 of the x's there. And we took out the only y that was there. So there's no y's left. And then you just want to close it. Number 5, doing the same thing. We're asked to factor. So anytime the instructions use the word factor, you'll want to check to see if there's a greatest common factor. 11, 3, and 9, if we just look at the number parts, nothing that's common to all 3 of those. If it were just 3 and the 9, you could take out a 3. But 3 is not a factor of 11, so no number that we can take out. But if we look at the variables, we've got an x in every single one of those. We can take that out. We've got a y in every single one of those. We can take a y out. And keep in mind, you do want to take out the greatest number. So you might ask yourself, can I take out x squared? Well, the second and the third terms don't have an x squared. They don't have 2 x's in them. So 1x is the only thing that's common to all 3 of them. 1y is the only thing that's common to all 3 of the terms. Then you want to write what's left. We didn't take anything out of the 11. We did take 1x out of x cubed, so that leaves 2 of them. We took a y out, so there's no y's left in that first term. Moving on to the second one, we didn't take out anything from the 3. We took out the x. We took out one of the y's, so that leaves 2 of them there. Then moving on to this third one, didn't take anything out of the 9, but we did take an x out. We did take a y out, so there's none of that left. Number 6, 2x cubed y to the 4th plus 4x cubed y plus 10x cubed y cubed. Factoring again, you want to check to see if there's a greatest common factor. 2, 4, and 10. Hopefully you can spot, you can take a 2 out of all of those. We've also got an x in all of these, and the most number of x's that we can take out in this case is actually 3, because we've got x to the 3rd, x to the 3rd, and x to the 3rd in all 3 terms. And as far as y's go, we can take out one y out of all of them. Put your parentheses, and on these examples, we'll rewrite what's left. We took 2 out of this first term. We took 3 x's out, so no x's left. We took 1 y out, so that leaves 3 of them. Moving on to the second one, we took 2 out, so 4 divided by 2 leaves us with 2. We took out all 3 x's, so no x's left, and we took out a y, so no y's left. Moving on to the last one, 10 divided by 2, divided by the 2 that we took out. 10 divided by 2 is 5. We took out all 3 x's, we took out 1 y, so it leaves y squared. Number 7, negative 2y minus 26x. And I just want to make a point about factoring. If the first term is negative, you'll want to factor out a negative generally. So if the first term is negative, factor out a negative. The first term is negative, factor out a negative. You don't necessarily have to do that in this section, but there's going to be some examples in future sections where if you don't take out the negative, it's going to be a bit of a problem. So get in that habit now. Here we can take out a negative, and maybe you can spot. We can take a 2 out of both of those. We cannot take a y out of both. We cannot take an x out of both. So the negative 2 is the only thing that we can take out. Then you just want to rewrite what's left. If you look at this first term and divide by negative 2, you're just left with a y. If you take negative 26 and divide it by negative 2, be careful here. Negative divided by negative would be positive. 26 divided by 2 is 13. And we did not take out the x. Number 8, negative 25y plus 10xy cubed plus 25x. Factor, make sure you notice it starts with a negative. So we'll want to take out a negative. Here we've got 25, 10, and 25. Maybe you can spot a common 5 there. If we look at the variable parts, we cannot take x out of all of them. It's in 2 of them, but not in all of them. And if we look at the y's, cannot take a y out of all of them. It's not in the last term. So negative 5 is the only thing that we can take out. And then we're just going to divide everything by negative 5. So negative 25 divided by negative 5 leaves you a positive 5. And we did not take out the y. Looking at the second term, 10 divided by negative 5 gives you a negative 2. We didn't take out an x. We didn't take anything out of the y's. And then lastly, 25x, 25 divided by negative 5 is negative 5. And we did not take out the x. Number 9, completely factor by grouping. And we've got CR plus CT plus RY plus TY. Generally what that means when you factor by grouping is that, well, first off, if you're factoring, you want to check to see if there's a greatest common factor. Anytime you see that word factor. But if you look at this, we can't take C out of everything. We cannot take R out of everything. And that basically means that there's nothing you can take out of everything. But when we group, generally what that means is that you're going to pair the first two and then factor something out. If you paired these two, you could factor out a C. If we paired the last two, we could factor out a Y. So we'll go ahead and do that. So we'll group those two and factor. We'll group those two and factor. So here in this first pair, we can take out a C, and then we'll rewrite what's left. When you take a C out of this first term, you're just left with R. When you take a C out of the second term, you're just left with T. Moving on to the second parentheses, we've got a y that we can take out, a positive y. And then rewrite. When you take y out of that first term, you're left with r. When you take y out of the second term, you're left with t. So that's the first step. The second step is noticing that we've got a common binomial here, r plus t, r plus t. Anytime you have a common factor, you can take that out. So we'll go ahead and do that. The r plus t part we'll take out, and we're just going to multiply it by the things that were outside, the c plus y. Number 10, 60bz plus 5qv plus 6bz plus 50bq. One thing you kind of want to be aware of while you're doing these factor by grouping ones is sometimes they'll give you some numbers like 60 and 5. If we just look at these, 60 and 5. And if you were to pair off the first two, you could take out a common factor of 5. That would be nice. What they'll also do, though, is the number next to it, the 6, might pair better with the 60 when we go to factor this out. So in some cases, you'll want to swap these middle ones, especially if in the first pair there's not anything that you can factor out of the two of them. But if we go ahead and swap those, 60bz, and then we make this plus 6vz plus 5qv plus 50bq. We've only swapped the two middle terms. This will factor out much nicer. So if we group those first two, group the second two, and then factor them, here we can take out a 6 and a z out of the first pair. And then rewrite what's left. 60 divided by 6 is 10. We took out the z, so we've only got the b there. And then plus, looking at the second one, took out the 6, we took out the z, so that just leaves the v. Then moving on to the next pair, we can take out a 5, and we can take out a q. Then we'll just rewrite what's left when we take those out. You take out 5 and a q, you're left with v. 50 divided by 5 would have left a 10. We took out the q, and that just leaves the v, or b rather. And like the last one, the ideal here is that this parentheses and this parentheses are identical. And I know they look like they're not identical, but 10b plus v and v plus 10b are the same thing. So you can take them out. 10b plus v. Take out that common factor, and then we're just going to multiply it by the things that were outside. 6z plus 5q. Number 11, 40cq minus 2ux plus 5qu minus 16cx. If you look at the first pair, if we were to group those off, you could take a 2 out. If you look at the next pair, though, 5 and the 16 don't have anything in common. We can't take c out of both. We can't take q out of both. We can't take u out of both. So the second pairing, the second group, wouldn't have anything in common that we could factor out. So this is another instance where you'll want to swap the two middle terms. And when we do that, make sure that when we move the -2 over, it stays -2. When we move the 5 over, it stays positive. Okay, so swapping the middle two, we'll go ahead and group them. The first pair, 40 and the 5, we can take a 5 out of. We can also take a q out of both of those terms. And put your parentheses and write what's left when you've taken that out. 40 divided by 5 leaves you 8. We took the q out, and that just leaves c. Took the 5 out, we took the q out, and that just leaves u. Then moving on to the second grouping, remember what I said earlier about when you're factoring something that has a negative at the start, you'll want to take out a negative. So here we'll want to take out a negative, and between the 2 and the 16, you can take a 2 out of both. We can also, if you look here, we can take an x out of both. Then once we've taken that out, we're just left with a u on the first one, and negative 16 divided by negative 2 is going to be positive 8. We took out a c, or we took out an x, and we're just left with the c. Then from there, again, 8c plus u plus 8c. We want these to be identical, and they are, even though they're out of order. But you can take them out, 8c plus u. And then we'll multiply that by 5q minus 2x. Number 12, this is the last example. 4ab minus 9 plus 4a squared minus 9a. For grouping the first pair, nothing that's in common there. 4 and 9 don't have anything in common. We can't take an a or a b out of both. So this is another instance where we'll want to swap the middle terms. So I'll rewrite this: 4ab plus 4a squared minus 9, and then minus 9a. So we've got the 4 with the 4, the 9 with the 9, and we can go ahead and group them that way. First pair, we can take out a 4. We can also take out an a. And if you look at the first term, we took a 4 out, we took an a out, that just leaves b. Next, we took a 4 out, we took an a out, so that just leaves 1a. And then onto the next grouping, we've got a negative there, so we want to start by taking out a negative. And 9 we can take out of both. And then, so starting there, we're going to, we took a negative 9 out. If you take a negative 9 out of negative 9, you might think there's nothing left. But you do want to put a 1 there. This should multiply to get back there. Negative 9 times 1 does give you negative 9. And then moving on to the next one, negative 9 divided by negative 9 is actually positive 1. And we've got the a there. And just like the previous two, we want this parentheses part at this point to be the same, b plus a. 1 plus a is not the same, so you want to be careful that you notice that. If it was b plus a and a plus b, those would still be the same, but here they're not. So what this means is we're not going to be able to factor this way. And this would be an example of one that's not factorable.